Question 1, core 1. Press pause, write these set of triple brackets down, and press play when you are ready. So in this question over here, we're dealing with a set of 3 brackets. The first time we're seeing this, 3 brackets over here. So we want to tackle this in a slightly different way over here. So let's first of all look at these first set of pair of brackets over here, okay? Always the first 2. So step 1, let's look at the first set, okay? And let's expand this, and expand it via the crab claw. So we have this x plus 2, x minus 4, x plus 3. Okay, again, we're looking at these brackets over here, the first set. So x times x, x times minus 4, 2 times x, 2 times minus 4. So we'll do that in a nutshell. That's going to be x squared minus 4x plus 2x minus 8. Okay, now this will obviously equal, if we do this, simplify this, it'll equal obviously x squared minus 2x, if we simplify these 2 bits over here obviously, minus 8, and then we're going to add the bracket over here, x plus 3. So it's a nice easy step. You just do the crab claw for the first 2. A misconception is that some students do this. They multiply everything by x plus 2. Okay, so they multiply even this one over here by x plus 2 as well. But you don't do that. Just multiply this one by x plus 2. So step 2, let's get into the second step over here. Let's apply this technique, should we say, called the backward banana method. Okay, it sounds a bit funny, but it works, okay? And let's call that BB for short. All right, BB, just like crab claw was CC, we use CC over here, crab claw, this is BB over here. So let's write what we've got from step 2. So we've got x squared, we've got minus 2x minus 8, x plus 3. So what we do is this. Now let's just expand this backwards. So step 1, pay attention over here. In fact, I'll just highlight this because this is the first thing we're going to look at over here, the x. So we're going to do x times minus 8, step 1. Step 2, x times minus 2x. Step 3, x times x squared. Now we're going to look at the next one over here, which is the 3. We can highlight that as well here. And let's do the fourth step. So the fourth step over here would be 3 times minus 8. 3 times minus 2x. 3 times x squared. So let's do all of these respectively. And I'll just put the numbers over here. 1, 2, 3, 4, 5, 6. Let's do this. So the first one is minus 8x. Then it'll be minus 2x squared. Then it'll be x cubed. Now we'll deal with the 3 over here. So minus 24, minus 6x, and then plus 3x squared. So there we have it. Right, so that's step 2, the banana method. Pretty self-explanatory. You can see that over there. Step 3, let's simplify like terms. Simple as that. So we're going to look at step 3 over here. Okay, let's put simplify like terms. Okay, so like terms. So let's cross off each one individually. So let's look at our x cubed terms. We have one x cubed term over here. Let's write x cubed. How many x squared terms do we have? Well, we have minus 2x plus 3x, which is going to be plus 1x squared, or just x squared. And all the x's, we have minus 8x, minus 6x, minus 14x, and we have this one number over here, one integer, so we'll put minus 24. So that should be a final answer for this. It's the backward banana method. So look through this. You could do other methods, obviously, but we find this the easiest one by far over here. So that would be a final answer for this over here. There we go. Question 2. So press pause, write this formula down, make x a subject, and press play when you have finished. So here we're dealing with a different type of formulae. We're dealing with a formulae initially involving fractions. Okay, so we can put an imaginary 1 underneath this first of all, because whenever you see, let's say, a fraction, let's put a 1 there because this allows us to do cross multiplication. Okay, so we can put brackets around here. It's more helpful. They'll never put brackets, by the way. When you have two of these terms, it's always going to put brackets. So this times this will always equal this times this. Okay, it's a fact. So 4 minus x will always equal y x minus 3. Okay. Now, when you see a bracket, let's multiply this out. So 4 minus x would equal xy minus 3y. Okay, now it's very similar to the question before. Let's get all the x's on one side. We have two x terms over here. We have a minus x and we have an xy. Okay, so those are two over here. Let's just highlight that a bit more formally with a green box. So those are our x terms. These are our non-x terms over here. So let's get all the x's on one side so we can get this. Now in this case, I'm going to bring the x's on the right side only because we're going to have positive x's when we do this. You see? So the minus x became a positive x over here. And this will make a positive 3y as well. You could take all the x's on one side, but we'll end up with all negatives and dividing by negatives, but it'll give the same answer. But this is a preferred method over here. So we have two x's now on one side. This is what we like. We want this, two x's on one side, you see, because it allows us to now factorize this. Let's factorize this. X outside, y plus 1. Leave 4 plus 3y over here. Therefore, 4 plus 3y all over y plus 1. And that's how simple this is. This has to be in the right order, though, for this to make sense. We can put a bracket in there. It doesn't make any harm. Okay, so look through that. Look how we used the idea of fractions, the first f, and factorize to get this answer over here. Question 3 challenge. So press pause, write this question down, press play when you are ready. So this is an example of triple LAV, and how we know this, because obviously we have three shapes A, B, and C over here. The word similar means obviously mathematically similar, which translates to LAV. Should have guessed that by now. So the surface area of shape B is 9 centimeters squared, and the surface area of shape C is 16 centimeters squared. So that's good. We have two shapes there, which we know the definite area of. The ratio, okay, the ratio now of the volume of shape A to the volume of shape B is 64 to 125. So the question is saying find the ratio of the length of shape A to shape C. Well, first of all, let's try to fill in the LAV table. Let's do these 3 steps and find out the LAV table. So number 1, is it obviously LAV? Well, yes, it's got similar. The word similar, so it has to be. Number 2, let's draw the LAV table over here, a 4x4. Now, if it's if it's 2 shapes or 3 shapes, we still do a 4x4. We'll call this A, B, and C here. We won't write a separate column for the ratios. A, B, and C are 3 different shapes. Now, what do we have over here? We have the surface area of shape B is 9, so this is 9 over here, and the surface area of shape C is 16. So we have 2 nice numbers over here, which represent the actual surface areas of shapes. Now, the ratio of the volume of shape A to the volume of shape B is 64 to 125. Now, this is the ratio, not the actual given volume. So if the ratio is this, we can say this is going to be 64 here, and this is 125. It doesn't make a difference what these numbers are. These aren't as in what these numbers are in the actual volume, because these are actually the representative of the ratio. So we can write this. The ratio can represent the actual volume. Okay, remember that. So let's try to go back to this first row over here, the first row of L. Remember, we want to find out this row over here. Once you have that, you can do anything with the question. And in particular, this question is asking for the ratio of the length of shape A to the length of shape B, hence the length over here. Okay. Now, if we have a scenario where we have, let's say, A dot dot B dot dot C, this should help us to understand the relationship of the lengths between all these 3 shapes over here. I know in this question we want to deal with these 2 over here, with A and C, but if you have A, B, and C, it'll help us be more flexible with perhaps other questions within this. So let's go ahead with this. Let's try to find out this first row. So let's first of all look at the 9 and 16. How can we create these 2 numbers over here? Well, the relationships will always be of B and C 3 dot dot 4, because if we square root these 2, i.e. 9 and 16 represent the areas, if we square root that, we're going to get 3 over 4. These are the actual numbers over here. Again, for volume, 64 and 125, if we actually cube root these over here, we're going to get 4 and 5. Now, you must be looking at this and going, hold on, we've got a 4, 2 numbers in here, and a 4. It doesn't make sense. Well, actually, it doesn't really make sense because it doesn't look right over here. But what we're trying to say over here is that 4 and 5 represent the relationship between A and B, and 3 and 4 represent these two, B and C. We need to put them all together. So if 4 and 5 is A and B over here, and also 3 and 4 is B and C over here, this can form a nice kind of relationship. I think we covered this in advanced ratios, where we have a lowest common multiple. We can simply times every single thing by these numbers. So we're going to times everything here by 3, because of this number over here. Times 3, times 3. And everything in the bottom row by this number 5. And times 5 again over here. So we're going to get this. If we do that, we're going to get this A dot dot B dot dot C times this by 3, 12 dot dot 15 dot dot 20. Now we only want this one. We only want 12 and 20. So the answer would be 12 dot dot 20, which could be broken down even more further into, let's say, if you keep halving this, 6 dot dot 10 or 3 dot dot 5. So that would be the final answer of the relationship of only B and C in terms of their length. So we'll highlight that over here like that. Quadratic inequalities. Let's write down this graphical illustration, and let's try to create a quadratic inequality from these two diagrams. So press pause when you have figured this out. Press play. Now let's read the question over here. Question 2, it says the area of the rectangle is greater than the area of the parallelogram. All measurements are in centimeters. Find the set of all possible values of x. So we have two different shapes here, and we should identify the area of this rectangle, of being obviously base times height. That's pretty easy. We'll put a bracket here because there are two terms, x and a number, and the area of a parallelogram being base height times the perpendicular height, i.e. 3x times x. These aren't given in any formal booklet, but they're quite easy from your work in previous years. Let's try to do step 1, and step 1 is to create an inequality, create and solve, should we say, a quadratic inequality, or in this case an equation, because we want it to equal 0. We identify it as this is a quadratic. You'll see why in a second. So step 1, let's do this. We have the area of a rectangle, 2x minus 1, 3x plus 2. This area is greater than 3x squared. The way we get 3x squared is 3x times x. Let's simply write this as an equation over here, the 3x plus 2 equaling 3x squared. So let's now expand the brackets on the left hand side and try to solve this. We're going to do 2x times 3x, 2x times 2, minus 1 times 3x, and minus 1 times 2. Now if we do this, what do we get over here? So let's expand this now, and we're going to get 2x times 3x, so 6x squared. 2x times 2 is 4x, minus 1 times 3x, minus 3x, and minus 1 times 2 is minus 2. This is all greater than, should we say, 3x squared, but we'll just put 3x squared over here like this. Let's bring this 3x squared to make a minus 3x, so 6x squared minus 3x squared is 3x squared over here, plus 4x minus 3x is plus 1x minus 2 equals 0. This is the advanced quad box now, obviously, because we have a coefficient now of 3 over here. So let's find two numbers and multiply to get minus 6, add up to get the 1 over here. And this would be 3 and minus 2. 3 and minus 2. So we'll have 3x squared, let's say, plus 3x over here, minus 2x minus 2 equaling 0. We'll half this over here. We get to factorize the first set, 3x, x plus 1, and x plus 1 again over here. We'll put minus 2 now backwards like this. So this now gives us the two numbers in front of your brackets, i.e. 3x and minus 2. We'll put 3x minus 2 and x plus 1 equaling 0. Therefore x would equal 2/3, or x would equal minus 1. Let's just obviously highlight this key equation as well. The whole point of this was to create it in this format over here, 3x squared plus x minus 2 equaling 0. Okay, so we've solved it. We've got two values of x equals 2/3, x equals -1. Let's try to sketch this now over here. So to sketch the graph, we'll do this. Step 2. Step 2, let's sketch the graph. So we're sketching this one in red, obviously. Let's say y equals 3x squared plus x minus 2. So to sketch this, we need obviously 3 different steps. You should know this by now. First step is the shape, step 2 is the y-axis, and step 3 is way across the x-axis. So it's a general positive happy face because of 3. It crosses over at -2 over here. This is 0, -2 across the y-axis, and part 3 crosses over these 2 points, 2/3, and let's say -1. This is a sketch, by the way. -1, 0, and this is 2/3, 0 over here. Let's roughly sketch this, and we're going to use now step 3 to show you what to do. So really rough, this goes like this and like this. Step 3, let's create our dashed lines now. Our dashed lines from this example. So step 3, dashed lines. Dashed lines means the lines on this graph which satisfy this inequality. The inequality is 3x squared plus x minus 2 is going to be greater than this sign over here. We're going to bring back to this. We looked at greater than because it's greater than like this into this last stage 3 over here. So this would be greater than 0. So the dashed lines would be what x values give you the corresponding y values that are greater than 0. It would be these 2 arrows over here. If you look at this, these 2 quadrants, should we say, anything greater than y equals 0, this and this. So those would correspond to these ones over here. We'll put these in this color over here, this brown color this time, and this will be greater than 0. All these x values will be greater than 0 as well. So in a way, we're looking at these x values over here. Anything that's greater than x equals 2/3, or anything that's less than x is equals -1. So let's read up the graph. X would be less than -1, or x would be greater than 2/3. So 2 separate equations over here, or separate inequalities, should we say, because obviously they are above y equals 0. Okay, so that's how you write this question. The 3 steps to do this. Press pause, write parts A and B down. Press play when you're ready. So this particular question is about the third type of learning objective in this video. It's called show solutions. So part A, show that the equation x cubed plus 5x minus 3 has a solution. All right, we're going to show these solutions between x equals 0 and x equals 1. It's just a matter of simply plugging these 2 values in. Okay, so all we're going to do is plug these 2 things in. Wherever we see x equals 0, let's plug it over here. So let's write x equals 0 and 0 cubed plus 5 times 0. You can do this, by the way, in your head if you, but you know, worth working out. It's pretty simple. So you know, we've got 0. We've got 0 here again. The answer is -3. That's below 1. That's quite good for us over here. Okay, we want a value below 1, a negative value. Okay, now x equals 1. Let's plug this in again over here the same way we've done above. 1 cubed plus 5 times 1 minus 3. So that gives us a value of 1 plus 5 is 6. 6 minus 3 is 3. We have a positive value for y, hence it's a positive value over here. Don't worry too much about why this is positive, negative at this stage. These just represent obviously the y corresponding values, and obviously if you understand from an axis, we're looking at an axis, looking at values below and above this over here. So this one over here, when x is 0, we get a negative value of -3. Okay, and when x is 1, we get a value of 3 over here. Okay, so that's why the root has to lie in the middle over here. If you look at these two things over here, I do a little scale over here as well. Right, this one here represents this one over here, and this one over here represents the other one. Let's have a look. If I were to do this over here, let's say this one over here, that represents this one over here. Okay, and it's going to be obviously in the middle. We join them up somewhere. We don't know where though. Okay, that's why it's in the middle. See, somewhere over there between that. So we know x has got to be really between, x is 0 and x is 1. We don't know exactly where it is, but this is where we're going to use part B to find this out. So this part B is all about rearranging the second part of this video. So let's do this trick over here. Let's write the answer x equals 3 over x squared plus 5. Let's go backwards. Let's multiply everything by the denominator. We don't like these denominators of fractions, so we're going to multiply everything by, if we just do this, a quick little showing you this little trick over here. Everything by x squared plus 5. So we get x squared plus 5 equals 3. Let's just expand that. Expand this over here on top. X cubed plus 5x equals 3. Okay, so this is the same thing as this, obviously. This. Now we want to get to, again, this. We want to get to this stage over here. Remember, we want to get to that stage. How can we make it look like that? Well, very simple. We'll take away the 3 over here. So let's take away the 3. So if we do this over here like this, and we take away the 3. So take away the 3, we get the original one snap. X cubed plus 5x minus 3 equals 0, which is snap with the original equation over here. If we look at the original equation, this and this, they both snap. Okay, obviously let's change these around. You've got to change these around, obviously. So the minus here will become a plus. Okay, and the times, you've guessed it, will become a divide. So this is a smart way of doing this question, the flipper effect, to rearrange something, and that's how we get the final answer over there. Question 3, parts C and D. Course 3, press pause, write this question down, and press play when you're ready. So this is simply a continuation for parts A and B from question 3, and what we're trying to find out over here is actually trying to churn out the actual values of x, or solving the equation, to put it more simply. Okay, so in part B we actually we rearranged the equation, and what we're going to do over here is simply write xn plus 1 to make this a formula, so we can create the iteration process from this. So let's do this first of all, and let's try to churn out these values of x. Okay, so we'll look for initializer. We're going to apply this formula, initializer, and our formula over here, 3 over x squared plus 5. So initializer, let's have a look. So this is what we plug into the calculator. We plug in 1 and an equal sign. Okay, done. Press clear. You don't have to, but let's go to our formula stage over here. Let's see how we can apply it over here. So we 3, because there's a 3 there, divided by, oops, there we go, divided by, now this is the trick, answer. Okay, answer represents x, or what we plugged in the initial stage over here. Now we're going to square this, square it, x squared, there may be another button on your calculator, but square that. I'm going to add 5. Okay, we're going to press equals now, once, twice, 3 times, and let me add one more box actually over here, because we're going to do this 4 times, because the question says 4. We didn't see that. So 4 times, and hopefully we should get an answer of the actual solution to this. So let's write this down on the calculator, please, and let's see. We press it once, we get x1, which is 0.5. Press it again, we get 0.571. Press it again, equals 0.563, and again the last time 0.564. So these are all the respective x1, x2, x3, x4. Okay, we can continue pressing equals if we'd like to do that all day, and we'll get an answer very, very, very close to the true solution. So part D kind of answers that. So by substituting your answer from part C into the original equation, comment on the accuracy of your estimation to the solution. Well, if you plug in, let's say, the last one of these, x4, into our original equation, let's say we did that. We did 0.564 cubed plus 5 times 0.564 minus 3, we would get an answer very, very, very close to 0. In fact, we got 0.00154, which is not 0 because obviously it's the 4th attempt on x only, but I guarantee if you were to press this, let's say 1,000 times, we'd get an answer very, very, very close to 0 because it's more precise.